So the next topic, now that we've talked about the key hook methods, process stream, process input, which demonstrated certain Java 8 features of streams, then we talked about print phrases, which demonstrated a few more. Now we're going to talk about the helper methods, and those are going to demonstrate even some more interesting capabilities. And these are the things that we actually use to read in the input data and read in the input files, which are the works of Shakespeare, and then also read in the phrases. And this will show off a few other cool Java 8 features that are neat. So you can give the input in a couple ways. You end up initially having a file that contains all the works of Shakespeare, and I got this from the MIT open source work of Shakespeare collection, and I went through and I modified it ever so slightly to put a little @ sign at the start of each play. So this is got one file that has everything in it, and then I just put a little @ sign to separate these things. And you'll see I use the @ sign with this method called getSharedInput, which is going to split this file up by the @ sign. So we'll end up with essentially a list of care sequences, where each care sequence is going to be, each list of care sequences will be the content of one play, and the list of care sequences will be all the works of Shakespeare. And then the other thing I do is I read in the phrase list, which, as you can see, is just a file of phrases, which are what we're going to be doing searching for. And each phrase appears on a separate line. So that's the input format. So let's go ahead and take a look at how those different methods are implemented, and it's kind of cool. It'll demonstrate a few other interesting Java features. So here's getInput. This is going to read the file into a list of strings. And so this is going to return a list of care sequence as a single result. And so what this is going to do is it reads in the file, and it goes ahead and converts the file name into a path name by using something called getSystemResource. And this is useful when you package up your applications and want to store files as a resource. So these files are stored as a resource as part of the app. So now I can go ahead and grab the resource, which is the file. I convert that into a URI. So now I've got a URI into the file system where this thing occurs. I then go ahead and convert that URI into a path name, and then I read all the bytes of that file into a string. So I make a new string that contains all the bytes of the file. So now I have one string that has all the bytes of the works of Shakespeare. And then what I do is I go ahead and I compile this, and I'm converting what was passed in here as the split parameter, which is that, in this case, it's the @ sign. And I'm going to go ahead and compile a regular expression, which will then split the bytes that contain the works of Shakespeare up into a stream, where every element in the stream is a string, or in this case, a care sequence. And I've split it by the @ sign. So as a result, what I'll end up with is a stream of strings, or care sequences, where each string is going to correspond to one work of Shakespeare, splitting using the regular expression. So I think that's pretty cool. Really simple to do. Didn't require a lot of extra processing. So I split it all up into a stream. If for some reason there were empty works of Shakespeare, which they're not, but if there were, this little filter will get rid of stuff that is empty. So if the string is empty, we negate it. We basically cast the string is empty method reference to be a predicate to a string, and then that allows us to get the negate method. So we negate it. So what that's saying is only allow non-empty strings through the filter, and then we go ahead and collect everything into a list of strings. So we end up with a list of strings or a list of care sequences as the result. And so there's a couple different things we can do here. This would create a list of strings, but there's other things we could do as well, and this is actually what I do in my solution. I go ahead and basically create something called a shared string, and that will allow us to be able to optimize the result so that we end up not having to actually copy the contents of the string. It's a bit of an implementation detail, but it sped things up when we talk about splitterators later. Get phrase list takes a file. Once again, we go and find that file in the resources directory. And in this case, this is kind of cool. We open up the file, and then we go ahead and split it into lines. Lines is a factor method that's part of the files class that will convert the file into a stream of strings. And it does that based on new line characters. So whenever it sees a new line character, that's what it uses to consider the end of the line. So it reads all the lines from the file into a string, so we convert those things into a stream of strings. We get rid of any empty strings that happen to be in the stream using the negate method, and the isEmpty method as before, and we collect those things into a list of strings. So again, this is just illustrating how easy it is to do text processing operations using Java 8 streams capabilities. And you could do it other ways, but it would just require extra work on your part.